Exercise 5.145. The first thing we should do here is to find the derivative of this function, or the gradient function, or stigningstalfunction, or what you would like to call it, and that should be fine. We just move the number 3 down here, so we get 3 and then times x to the power of 1 less than 3, 2. Keep my constant 6, move down 2, so I get 2x, and plus the derivative is 12x is 12. And the number minus 8 disappears, so we get 3x squared minus 12x plus 12. That's the thing here. And then we should find the equation of a tangent line. We just put up the point gradient formula. We need x1, which is the x coordinate, is 1. We need y1, which you have to calculate here by putting the x coordinate into the function. And we get 1 to the power 3 minus 6 times this plus 12 times 1 minus 8, which is 1 minus 6, which is minus 5 plus 12, which is 7, the minus 8, which should be minus 1. So that is the y coordinates. We have the point 1 minus 1. That's the point, tangent point. Then we need a gradient, the stigningstal, and then we just put the x coordinate into stigningstalsfunction. And we get, here is the derivative, put 1 in here, 3 times 1 squared minus 12 times 1 plus 12. And this will be 3, like this. And then we just put it into the point gradient formula here. So we get y minus y1, which was minus 1, equals to a, which is 3, times x minus x1, which is 1. And then we get y plus 1 here. We get 3x minus 3. And then I just move over here, so I get 3x minus 3 minus 1, which is y is equals to 3x minus 4. So that was the answer on exercise B. And then in exercise C, it says here, does the graph of f has one or more other tangent lines which are parallel to the one we found here? And if this is a straight line, right? This is a straight line like this. And if a tangent line should be parallel to this, it has to have the same gradient. So we wonder if are there any other x's here which gives us a gradient of 3. Right? If the derivative is equals to 3, the gradient is equals to 3. Right? So we have here is the gradient equals to 3 somewhere, and maybe here. Right? So I solve this equation. We normally solve equals to 0. Then we find the maximum minimum point. If I put it equals to 3, I find all the points where the tangent line has gradient 3. So I have to solve this equation. 3x to the power of 2 minus 12x plus 12 is equals to 3. This is the derivative. So I just get 0 on the right hand side, move this over, and I get plus 9 equals to 0. And we can factorize here. We have 3 in common, like this. And we can use the shortcut here on this one. And we get x equals to 1 and x equals to 3. And this answer is the point we already have done a lot bit already. So we have calculated this is this point, but we see there is a different answer here. So there's another point where the gradient slope of the gradient is equals to 3, which means that the answer is yes. When x is equals to 3. So that was exercise 5.145.